two problems of the Gauss-Seidel method. In the first numerical problem, we have considered only the two buses are the load buses and the one is the slack bus. In the second problem, we have considered the one is the slack bus, another is the PV bus, and another is the load bus. Now, the same problem that we have discussed earlier, we will solve by using the Newton-Raphson method. So this Newton-Raphson method is a very fast and it does not depend upon the size of the system. That is a main advantage. So that's why it is mostly used in the power system. Now what is the first step? We have to determine the Y bus. That part we have already discussed how we will construct the Y bus. Now what is the important thing is that earlier we have used the Y bus in the rectangular form, but here we have required the Y bus in the polar form. So what is this minus J60? The 60 angle, that is the basically 1.57. This is the important thing. If we have to determine all the angle in radian, this is the major important point. So what is this is 1.57 and this value will be negative. Okay. Similarly, this becomes 40 plus 1.57. This is 20. This is 1.57. And this 1.57 is the equivalent of the degree is a 90 degree. Okay. For positive. And for negative, it is a minus 90 degree. Okay. Now this becomes the 40 plus 1.57. This becomes 20, 1.57. Then this is the 80 minus 1.57. And this is the 40, 1.57. And this is 40, 1.57. This is 60 minus 1.57. This is the important thing. In the Y bus, we have to determine all the angles in the radian, not in the degree. Okay. Now this is our purely the reactive line. So that's why the angle in the degree will be plus 90 or minus 90. And the corresponding in the radian are the 1.57 or minus 1.57. This is the first step. Now, step number 2. That is the important thing. We have to draw the structure. That is a very important thing. Structure of the Jacobian matrix J for this problem. That is a very important thing. If you will understand this concept carefully, we get how we will determine the Newton-Raphson method for any problem. Okay. Step 1, the Y bus in the polar form and the angle was in the radian. So next step number 2, we have to determine what is the ith power formula. That is Pi and Qi, where K is the number of iteration, which is a summation of J vary from 1 to n. These all are the modulation indicated that we have to consider only the magnitude value. Mod of Vi, mod of Vj, Yij. This Y is a capital. Okay. This is also same. But difference is here is a positive, here is a negative. Now cosine of theta ij minus delta I plus delta j. Now how you will remember this formula? Okay. So this is the active power P. So we very well know that in the P there will be always cosine terms, and in the Q there is always sine terms. First thing is this. Second, the reactive power is the negative, so that's why it is a minus. This is summation is from J to 1 to n, that is for all the n buses. Now what is this? This first term is common. This is a Vi, Vj and Yij. So you have to remember this in the sequence. Okay. And after that, when you have to put what will be the angle? The angle will be first the angle of the admittance, which is the cos theta ij. Now, what is the theta ij? That is the admittance angle. Okay. That is the important thing. It is the admittance angle. What is the delta I? That is the angle of the ith bus. What is delta j? That is the angle of the jth bus. Okay. Similarly that. After when we will expand this equation 1 and 2 using Taylor series, then we will get the structure of the Jacobian matrix G. This structure is very important because सारा खेल इसी structure का है. Okay. So if the system has all the load buses, have some PV buses and load buses, this formula will be common for that. Okay, and for any system we always use the one bus or bus number one, okay, as a slack bus. So when we will consider the slack bus as a reference bus, then how many the remaining buses are available? N minus 1. This is an important thing. That's why reason you will see here in the left hand side, when we will determine these are the change in the power. What is the delta P2? It is a change in the power. For the kth iteration, change in the power of the bus 3 for the kth iteration up to the Pn bus. Why starting from the P2? Because we have already considered that there are the first bus is the slack bus. So how many is the basically rows? N minus 1. And how many column? Only 1. So what is basically the size of this N minus 1 into 1? Similarly, the reactive power, okay. So what is this reactive power? Delta Q2K, delta Q3K and so on. Again, because we have considered the bus 1 as a reference, so it will also start from the Q2, then Q3 up to the Qn, okay. And how many rows again there will be, okay. Now, similarly, see on the right hand side, first this is the vector, okay. What is delta D2? The change in the rotor angle, okay. Or for the kth iteration, this angle is corresponding to this change in power. This delta 3 is a corresponding the change in angle corresponding to the power, okay, and so on. Again, why we starting from delta 2? Because we have chosen the bus 1 as a reference, so that again there will be how many terms? There will be n minus 1 terms. Okay, very well. Now come to the Jacobian. I have shown a dotted line in between there. Okay, and this dotted line will segregate this whole matrix into 4 parts. This is 1, 2, 3 and 4. Now how we will deal this individual the sub-Jacobian matrix, we will as follows. The column vector we will discussing about the elements of the Jacobian, okay. So this is the complete the Jacobian matrix, okay. Now I have divided this Jacobian matrix into the 4 parts. So this part is called as the J1. Now what is the size of this J1? Is the n minus 1 into n minus 1. Why? Because I already told you there are the n minus 1 remaining buses, because we have selected the one bus as the slack bus. So how many buses will be? N minus 1. So these are the terms delta P2 upon change in delta D2, that is a partial derivative of the P3 with respect to delta 2. Similarly, the last, what will be the last term at here? Delta P3 upon, this is the for nth bus, so this become Pn delta 2 whole to the power k. So this is the nth bus. So 2 to n, so that's why there will be n minus 1 rows. And similarly, when we go move in the column, so what is this? Delta P2, but here the denominator is changing. What is changing? With respect to delta 2, with respect to delta 3 and up to delta n. Again, this delta 2 to delta n, how many number of the elements? Again n minus 1. That's why reason these are the n minus 1, and this n minus 1 will decide the size of the sub-Jacobian matrix. Okay. Now, what is the second this structure? This is denoted by J2. Okay. Now, what is this size? Again, the power is this, that is a change in the partial derivative of the P2 with respect to modulation of the V2, P3 modulation of the V2 and so on. अब यहाँ पे last term क्या आएगा? Delta Pn upon modulation of the V2 with respect to and for kth iteration. So again P2, P3, Pn. Again how many terms? N minus 1. But how many voltages are given. That is the important thing. That is a V2, V3, Vn. Okay. So here the column will be n minus 1 minus m. Now what is this m indicated? That is a very important thing. Number of PV bus. Number of the PV bus. Okay. So now how it is minus 1? We will discuss later on. Now similarly, come to this is called as the J3. Okay. Now these are basically the reactive power. There is a partial derivative of the reactive power with respect to delta 2, partial derivative of the reactive power at bus 3 with respect to delta 3 and so on. The last term क्या आएगा? Delta Qn upon delta. Okay, now this is the delta 2 and up to the with respect to the delta 2 and this become K. So how many reactive terms are come? Q2, Q3 up to the Qn, and we know very well the reactive power are associated with the PV bus. Okay, so that's why here again there will be how many rows? N minus 1 minus m. Okay, and here there are also the voltages, and voltages are associated with the PV bus. So once the PV bus will come in the picture, then the size will become n minus 1 minus m. So what is the column corresponding? They are delta 2, delta 3 up to delta n, delta 2, delta 3 up to delta n. Okay. So basically that will be the, how many terms will be? N minus 1, because this delta 2, delta 3, delta n and so on, that will be basically your for the n minus 1 buses. And the last, this is called as the J4. Now what is this J4 size? Which is n minus 1 minus m into n minus 1 minus m. Why? Again, because this reactive power and voltage, they are associated with the PV buses, and for the PV buses, basically the numerator represent the rows and denominator decide the column. Okay, so here the numerator is the change in the partial derivative of Q2 with respect to V2, Q3 with respect to V2. The last term क्या आएगा इसमें? Qn with respect to mod of V2 and for the kth iteration. So Q2 to Qn, okay, so they all are again relevant to the PV bus. So this row will n minus 1 minus m. And what are the columns? The columns are basically again V2, V3, Vn, and these V2, V3, Vn they are associated with the PV bus. So this size will be n minus 1 minus m. Okay, so we have to remember carefully the size of all these sub matrices. Now what is the final size of the J? That is a very important thing. Now the J is basically the structure is look like this: J1, J2, J3 and J4. So what is the final value of or final structure of the J? The size of the J. Okay. Now, how we will deal this problem? Now, see here. For example, we will first case for 2-bus system. Okay. हमने एक बहुत सिंपल प्रॉब्लम ली है जिसमें सिर्फ 2 ही बस है. ओके. अब उस 2 में भी एक बस हमारी क्या है? स्लैक बस. ओके. In 2 bus, the slack bus is 1 and PQ bus is number 2. Okay, तो हमारे पास 2 बस है, एक slack बस है और एक PQ बस है. Okay, there is no PV bus. Okay, no PV bus. So for this case, what is the M will become 0. तो हमारे पास कोई PV बस ही नहीं है, तो what will happen? M will 0. So what is the size of the J1? When n will be 2, so what is this become? 2 minus 1, 1. So J is 1 cross 1. What is the J2? This is a n become 2, m becomes 0. So what is this become? 1 cross 1. What is J3? Okay, what is this? Is J3? M is 0. So this also become the 1 cross 1. What is J4? This is also become 1 cross 1. It means for a 2-bus system, what is the J? The J is the nothing but a 2 by 2 matrix. This is a very important thing. Okay. Now what are these elements? Because it is 1 cross 1. So what is this 1 cross 1? We have considered only this. So this is delta P2 upon delta 2 K. Okay. This is J2. Again 1 by 1. So delta P2 upon. Okay. What is this? Delta V2 K. So this is the J3. So this become delta Q2 upon delta 2 K, and this is a delta Q2 upon delta V mod of V2 K. So this will be the structure for a 2-bus system. This will be J. Okay. Now another important thing. Now these the left hand side quantities. Okay. So here what is this? This is the n minus 1 minus m. Okay. And this is also the size will be n minus 1 minus m into 1, and this will be also into 1. Now what are these? These quantities we have a given quantities. Mind it carefully. ये हमें given होगा, और these quantities are the unknown quantity जो हमें निकालनी है. Okay. So basically we are given these quantity and we have to determine these unknown quantity. Okay. Now what will happen? What is this P2? It means what is the P2? Because this is our bus number 2 is the load bus. Okay. So what will happen at the load bus? We have know the P2 and Q2. Okay. It means we have to determine the change in the power with respect to delta 2, the change in the reactive power with respect to delta 2. Okay. So what will happen at the here? Okay. Then we have to determine the change in the P2 with respect to V2. What is the V2? The load bus voltage. And similarly, the change in the reactive power with respect to the V2. So basically, using this P2 and Q2 equation, we will determine all these the 4 derivatives. Okay. And what will be that here? These are the terms. That is our unknown terms. So unknown terms become, this is the delta 2k. Okay, because n is the basically your 2, 2 minus 1 is 1. Okay, and here m is 0. So this will be delta V2k. So these quantity we have to determine, because this is our the load bus. So at the load bus, what are the unknown quantity? The voltage and the delta. Now what we have given, again the left hand side, that is the delta P2k and delta Q2k. So these are the basically the given quantity, that is the delta P2k and delta Q2k. Okay, so this is the given quantity, this is the unknown quantity, and they are related through the Jacobian G matrix. Okay, this is the simple structure of the for a 2-bus power system. Because once you know the structure of the Jacobian, after that there is a total mathematics. If you have drawn the wrong structure, then your numerical will be wrong. Okay, this one, that is for 2-bus system. So we consider the 3-bus system. Okay, now in 3-bus system, suppose we have assumed the bus number 1, bus number 2 and bus number 3. That is about the same problem that we have solved by the Gauss method, Gauss-Seidel method. Okay, In our this case, the bus 1 was the slack bus 2 was our PQ bus, and bus 3 was the PV bus. Okay, as it is the same problem. Now what will happen in that condition? There is a one PV bus. So what is the value of M is 1. Okay, N. What is the value of N? N equals to 3 because 3 bus system. And what will the corresponding the Jacobian J1? Because it is a 3. So what does this become? 2 cross 2 because 3 minus 1, 3 minus 1, 2. Okay. What is J2? So see here 3 minus 1, 2. Okay. Now this is M is 1 because 1 PV bus. Okay. What is this 1 PV bus? So 1 plus 1, 1, 1, 2, 3 minus 2, it is 1. So what is this size? 2 cross 1. Now what is J3? See here. This J3, the N is 3, M is 1. So what does this become? 1 cross 2. And the last is J4. What is J4? N minus 1 minus 1. It is 1 cross 1. So basically, this is our all the sub-Jacobian size. Okay. So what will be the left-hand side? That are our given quantities. Now what is this? N minus 1 into 1. What is N? 3. It means this size will be 2 cross 1. And in case of 2 cross 1, there will be 2 elements. What are these 2 elements? Delta P2K, delta P3K. Okay. So what is this? N minus 1 minus M into 1. What is N? 3. What is M? 1 to 3 minus 2. It is 1. So what is this one term become? Delta Q2K. Okay. Equal to. Now what is J1? 2 cross 2. It means you have to consider the 4 element. Mind it carefully. Then it becomes 2 by 2. When J2 is 2 cross 1. Okay. It means 2 rows, 1 column. We have to consider this. J3. 1 row, 2 column. We will consider this. And J4. 1 cross 1. We will consider only this element. Okay. So what does this structure become? This becomes delta P2 upon delta 2 for kth iteration. This becomes delta P2 upon delta 3 for kth iteration. Okay. This becomes delta P3 upon delta 2 for kth iteration. Delta P3 upon delta 3 for kth iteration. Now this is our J1. This is our J1. Now what is the J2? The J2 is 2 cross 1. That is this value. Okay. What does this become? Delta P2 upon delta V2 for kth iteration. What does this become? Delta P3 upon delta V3. Sorry, this is the delta V2 for kth iteration. So this is our the J2. Now what is J3? 2, 1 cross 2. Okay. So this become delta Q2 upon delta 2 whole to the power K. Then this become delta Q2 upon delta 3 for kth iteration. And the last is 1 cross 1. So this become delta Q2 upon delta V2 mod for kth iteration. Now what are the unknown quantities? It is again a 2 cross 1. Change in delta 2 for kth iteration. Change in the delta 3 for kth iteration. And the last is change in mode of voltage for kth iteration. So this is the complete structure for the 3 bus system. That is our problem. And in this problem, our size of the Jacobian is the total size is 3 cross 3. This is also 3 cross 1 and this is also 3 cross 1. Okay, it means if we know all these the 9 derivatives terms, for the first iteration we have to determine these 9 derivatives terms. We know this change value, then first iteration we will find out these the unknown quantities. Then again in the second iteration we will again determine these 9 derivatives, and again we will determine this change. Then we will find out the second iteration unknown quantities. This is the way of the solving the Newton-Raphson problem. Now in this we have taken the one assumption was that there was the basically the one slack bus, 2 PQ bus, and number 3 is the PV bus. Okay. Now suppose I am doing a smaller changes. Again for 3 bus system. Again bus 1 is our slack bus, and bus 2 and 3 both are the PQ bus that we have discussed the 6.7 question of the Gauss Seidel method when all the buses are the PQ. In that condition what will happen when n is again the 3, okay, and what is the value of m? M is 0. Why? Because there is no PV bus. So what is the Jacobian size of the J? Again it is the 3 minus 1, 2 cross 2. What is J2? Because M is the 0, so J2 is also 2 cross 2. What is J3? Is also 2 cross 2. What is J4? It is also 2 cross 2. That is a very important thing. Okay. So what are the basically the structure for that? Because this is n minus 1, so 2 cross 1. This is also 2 cross 1 because m is 0. So what are these terms? Delta P2k, delta P3k, delta Q2k, delta Q3k, okay, equal to, this is our Jacobian matrix. What are the unknown quantities? Change in delta 2 with respect to k, change in delta 3 with respect to k, change in mod of V2 with respect to k, change in mod of V3 with respect to k. And this Jacobian will be 4 cross 4, this is a 4 cross 1, this is 4 cross 1. Okay, it means when the all buses except the slack bus all are load buses, then the size of the Jacobian matrix will increase. Because earlier it was the, when there was a one PV and PQ bus, the size was 3 cross 3, but now it become the 4 cross 4. And once the size will increase, what will happen? It take the more time for the computations. Okay. And what are the corresponding elements of these Jacobian elements? That will be, now see here, this is also 2 cross 2. Okay. This is also 2 cross 2. And this will be also 2 cross 2, and this will be also 2 cross 2. That is the important thing. That means we have to put all these values at here. This is at J1, this will be at the J2, this will be at the J3, and this will be at the J4. Okay. So we have discussed, they are the basically 3 cases. If discussing the complete structure of the Jacobian matrix for the 3 cases, case 1, case 2 and case 3, we will come back to our problem, because our problem is basically relevant to case 2, and in the case 2 we have to determine the, for step 2, because in step 1 we have already determined the y bus, okay, in the polar form and where the angle in the radian. So this is the standard formula of the Pi and Qi for the kth iterations. Okay. Now what is our problem? In our problem, the bus 1 is the slack bus. Okay. Now bus number 2 is our PQ bus, and bus number 3 is our PV bus. That is same problem we have discussed earlier. Okay. Now then for I equals to 2. Okay, what does this equation become? P2k. This become j vary from 1 to 3. This become V2, Vj, yij. So in place of I will written 2j cos of theta 2j minus delta 2 plus delta j. Okay. Now all these modulations are indicated that the basically the magnitude. So I will not repeat again and again modulation. I will return the one line. Okay, all voltages and admittances are in modulus form. Okay, so that's we have to not put the again and again. Okay, now when we open this bracket, this become V2, V1, Y21. Now here I am not writing the modulation, okay, because I have specified, so that's the your time will be saved. This become cos of theta 2 1 minus delta 2 plus delta 1. I have put the j will be 1 plus, okay, the next term will be V2 square, because this is V2, j become 2, V2 square, this become Y22 cos of theta 2 2 minus delta 2 plus delta 2. So this delta 2 and delta 2 will cancel out. Then when you put the j equals to 3, it become V2, V3, Y23 cos of theta 2 3 minus delta 2 plus delta 3. Okay, so basically for 3-bus system, this P2 will consist of the 3 terms. Okay, similarly, when I consider the I equals to 3, what does this become? P3K, and I will written in the similar manner. What does this become? Now V3 V1 Y31 cos of theta 31 minus delta 3 plus delta 1 plus V3 V2 Y32 cos of theta 32 minus delta 3 plus delta 2 plus V3 square Y33 cos of theta 33 minus delta 3 plus delta 3. You know, here delta 3 will be cancelled out. I have written similar manner, look like this. So this is a P2, this is a P3. Now similarly, okay, I will determine, because these the powers we have specified at the, this is the at the load bus, this is at the generator bus. Now the last is the when I equals to 3. So what is my Q2? K. Okay, because this is the load bus data and this is our PV bus data, that is a given. So what does this become? Minus j vary from 1 to n. Okay, V3 Vj y, sorry, not this is 3 because we are for determining for the load bus, so the I is 2 and this is not the I3, so they are given data. So Vj V2j, this is Y2j sine of theta 2j minus delta 2 plus delta I, delta 2 plus delta j. This is not I, this is the j. Okay, now again open the bracket, minus V2 V1 Y21 sine of theta 2 1 minus delta 2 plus delta 1 minus V2 V3, this become V2 and this also become V2, so it become V2 square Y22 sine of theta 2 2 minus delta 2 plus delta 2, again delta 2 will cancel out, minus V2 V3 Y23 sine of theta 2 3 minus delta 3 delta 2 plus delta 3. Okay, so basically in the next step number 2, we have to determine these the power formulas. Okay, and in this power formula, okay, what are the thetas? The thetas are the admittance angle corresponding. Okay, now when we will start the iteration, so we will assume that our slack bus voltage is 1.025 per unit. Okay, now what is our V20? Initial voltage for the load bus will be 1.0 plus J0. Okay, so we have to take these assumptions. Now similarly, what is the V30? It is 1.03 plus J0.0. This is for PV bus. Okay. Now similarly, what is the corresponding angle? What is delta 10? This is 0.0 degree. What is delta 20? It is also 0.0 plus J0.0. Similarly, delta 30, it is also 0.0 plus J4. These are our assumptions value. Okay, for the first iteration. Okay, now, for example, if I am determining these equations for the first iteration, so what is the I become? Sorry, what is the K become 0? So what does this become? P20. What does this become? P30. What does this become? Q20. Okay. Now here also the K becomes 0. This become K becomes 0. Okay. Now what is the V2? We know the very well. What is the value of the V2? 1.0. What is the V1? 1.025. What is the Y21? That is we have already determined the Y bus matrix. What is theta 1? Corresponding angle in radian. What is delta 2? 0. Delta 2, delta 1, 0. Okay. So initially these angles are the zeros. So what will happen? And I already told you, because the line is reactive, so the angle of the degree plus 90 is corresponding to 1.57 and minus 90 is corresponding to minus 1.57. So what will happen when you put this value? The cos of 1.57 it becomes 0, cos of 1.57 it becomes 0, and cos of 1.57 it becomes 0. Why? Because delta 2, delta 3 and delta 1 all are the initially 0. So that's why for this first iteration, what will be my P20 will be 0. This is very important thing. Without any calculation we can return here. Now similarly, what is the P3? Now again the delta 1 and delta 3, delta 2 all are initially 0. So this becomes also the cosine of the theta 31. So this becomes 0, this becomes 0, this becomes 0. So finally what is my P30 is also 0. Okay, but my Q20 will not be 0. Mind it carefully. Why? Because here is the sign. Okay, again delta 2, delta 1 they are the basically the value 0. Okay, but this sign of the 90 or sign of the 1.57 this become 1. So this become 1, this become 1 and this become 1, and once they all are to become 1, so the Q20 will not be the 0 value. This thing is a very important. So basically at the initial stage for a lossless line we can easily determine P20, P30 by without solving the calculation. This becomes 0, 0, and this is always for any type of the bus system. The condition is that the line should be purely reactive. If this system is a 4 bus system, 5 bus system, okay, this delta P2 will be always 0, and this is 0 only due to that the line is a purely reactive. It means there is a no resistance, that's why it is a 0. Okay, calculating the P20, P30 and Q20, we will draw the structure of the Jacobian. Okay, this is called as the structure of the Jacobian. We have already discussed earlier. Okay, so basically the size of the J is a 3 cross 3. This column is a 3 cross 1. This is a 3 cross 1. Now these data we have given. Mind it carefully. This data we have to evaluate. That is the important thing. Okay. So first of all, we will determine basically the change in the power formula, that is the delta pi k, which is equal to the pi schedule minus, okay, the pi of k. Similarly, the delta qi k equals to qi schedule minus qi k. Okay, this formula we have to remember. Now for first iteration, okay, this k value will be 0. So what does this become? Okay, k equal to 0 and I equals to 2. What does this become? P2 0 equal to P2 schedule minus P2 0. Now what is P2 schedule? Because for the load bus, the value of the P2 is minus 4. What is P2 0? We have already determined earlier it was the 0. So what is this become? Minus 4. Okay. This is the delta P2. Similarly, what is the delta Q2 0 equals to Q2 schedule minus Q2 0. Okay. Now here this Q2 0 is not 0, mind it carefully. Now what is the Q2 schedule? For the load bus it is minus 2, minus depending upon the value we have calculated. Okay. We will put here, we get the Q2 0. Okay. And then when we will put I equals to 3 and k equal to 0 in this pth bus, so what does this become? Delta P3 0 equals to P3 schedule minus P3 0. Now what is P3 0 is 3.0 because it is for the generator bus, and again P3 0 is 0. So what is this 3.0? So basically we have determined the left hand side terms, that is this value and this value. Okay. Once we know this value, then our next step we have to determine the derivatives of the Jacobian. There are 9 derivatives. So we have to determine this 9 derivatives, and in general, okay, this Jacobian structure we can written in this form, that is a delta P delta Q equals to, okay, J times of delta and delta mod of V2. Now this representation is called as a vector form. Okay, so basically we have to determine this quantity. So what is this quantity? Delta mod of V2 will be J inverse of delta P and delta Q. Now delta P and delta Q, that is a vector form. Okay, we have already determined this. Okay, and these are the unknown quantities. These are vector representation. Whose internal representation is this, and we have to find out the first Jacobian, then take the inverse of that. And you very well know how we determine the inverse. The adjoint of a matrix divided by determinate's value. Okay, this is the way of the calculating the inverse of any square matrix. Okay, after calculating the change in the P2, P3 and Q2, what are these changes value? We have already determined in the last step. Okay, what was this? The P2 change in power was minus 4.0. What is this? Minus 3.0. And Q2 Depending upon that, the value we will determine. We know all these quantity. Now we have to determine this unknown vectors. Okay, so for we will determine the Jacobian elements. Now what is the P20? We have already determined. Okay, so first of all I will determine the first row of the Jacobian matrix. Okay, now I will return in this manner J1 1. Okay, I have written this is the, because this is the J1, this is J2, this is J3, and this is J4. So I have written J11. What is this J11? Delta P2 upon delta with respect to, differentiate with respect to delta 2. Okay. Now this is the delta 2. We will differentiate cos delta 2 of this function. So what is the differentiation of cos? Is a minus sign. But when we will differentiate the delta 2 is another function, so minus 1 and minus minus become plus. So what does this become? V2, V1, Y21 sine of theta 21 minus delta 2 plus delta 1. My point is clear. The differentiation of cos is the minus sign, but delta 2 is also a function, so what's the differentiation will be minus 1, so this minus and minus 1 plus 1. Now what is this here become? There is a no delta 2 term present, so what is the differentiation will be 0. Now last is this is the cos sign, again V2, V3, Y23, cos differentiation is a minus sign, but again the differentiation of the delta 2 is minus 1, so that minus become plus 1. Okay, so there are only two terms. Similarly, when I will determine the J1 first row second column, this is first row second column, what does this become? Delta P2 upon delta 2 with respect to 0. So here in this we have to differentiate with respect to delta 3. So you have to see where is the delta 3. Is there any delta 3? No. Okay. So what will happen? This term becomes 0 plus. There is any term of delta 3? No. This becomes 0. Now what is this differentiation? The cosine differentiation will be minus sign. Okay. That is the important thing. So V2, V3, Y23 cos is minus sign theta 2, 3 minus delta 2 plus delta 3. यहाँ पे प्लस 1 नहीं होगा because the delta 3 is a function whose differentiation is a plus 1, not minus 1. Okay, now next, if I determine, okay, this is the J2, okay, or if I am writing in general the J, okay, no, so that the confusion will not occur. So 1, 3, this is the J. Now what is this J? First row, third column. It is a delta P2 with respect to mod of V2 and is the 0. अब हमें V2 के रेस्पेक्ट में डिफरेंशिएशन करना है. हैव टू चेक वेयर इज द V2. इज दिस? तो V2 के रेस्पेक्ट में डिफरेंशिएशन करना है, तो होल रिमेन विल बी कांस्टेंट. So what is the differentiation of V2 is 1. So what does this term become? V1 Y21 cos of theta 21 minus delta 2 plus delta 1. Now what is the differentiation of V2 square? 2V2 Y22 cos of theta 22. Okay, because this delta 2 is cancelled out. Now what is with respect to V2? This V3 Y23 cos of theta 23 minus delta 2 plus delta 3. This is the way of the determining the first row elements of the Jacobian matrix. Now again, what is the initial value of the, basically the delta 1, delta 2, 0, delta 3 also 0. So again, what is the cosine of this function become? Cosine of the, this theta 2, 1, okay? Then this function and this function. So finally we have to determine what is the P2 0 with respect to delta 2. Similarly, okay, when we have differentiate this, so it becomes the sine, this becomes sine. So here this term will not be equal to 0. This will be also not equal to 0. But here they are cosine terms, and the cosine, the theta is a 90 degree or 1.57. So here this term will become the 0. That is the important thing. Okay. Now what are these values? We have to put the value of V2 is a 1, V1 1.025, Y21 that is from Y bus matrix, corresponding angle and initial angle. Similarly, when we determine J2 comma 1, J2 comma 2, J2 comma 3 in the same manner, now what is this value? Delta P3 upon delta 2, delta P3 upon delta 3 and delta P3 upon mod of V2 angle 0. Now P3 we have already determined. Take the differentiation with respect to delta 2, delta 3 and mod of V2 in similar manner and put the value. The last, that will be J31, J32 and J33, which is the nothing but the delta Q2 upon delta 2 of 0, then delta Q2 upon delta 3 of 0, and the delta Q2 upon delta mod of V2 0. Okay, Q2 we have already determined. Take again the derivatives with respect to delta 2, delta 3 and V2. There will be three equations. This is the way of the determining the Jacobian matrix J. Okay, all the elements of the Jacobian we will put in this 3 by 3 matrix form. Okay, and change in the power. No, here one correction, I forget this value of this element will be not the minus 3.0, it is a plus 3.0 because it is generator power, and generator power will be always the positive. Okay, now then we have to find out this vector elements. So what will be, this will be the Jacobian inverse multiplied by this term. Now how we will determine the Jacobian? That is adjoint upon the modulation. We get this result, multiply by this vector. Now we get finally this. So basically this is the delta 2, delta 3 and V2, change in voltage. Now after that we have to determine if for k equals to 0, what is the, and I equals to 2. Okay, so this will become delta 2 1 equals to delta 2 0 plus change in the angle. Now what was the initial assumption of the rotor angle for the load bus was 0. How much change we have get? Minus 0.0367. So what does this become? Minus 0.0367 radian. Okay, so this is the first iteration unknown quantity. Okay, so similarly when k equals to 0, I equals to 3, what does this become? Delta 3 1 equals to delta 3 0 plus change in the delta 3 0. What was the initial again? Again angle was 0 plus what is the change in angle? 0.0239. Okay, so this is our second unknown quantity, that is at the PV bus, the delta 3. Once we know the delta 2 and delta 3, then we can determine the what is the magnitude of the voltage. Now here again for I equals to 2 and k equals to 0, what does this become? Mod of V2 1 equals to V2 0 plus how much change in the voltage, that we have determined this 0.0026. What was the initial value of the V2? 1.0. Okay, plus how much this voltage? 0.0026. So what does this become? 1.0026. So this is the magnitude of the voltage at the load bus. Okay, so these was the three unknown quantities, two for the, that is a load bus, and one for the, basically at the your corresponding, we can say that is the generator bus. Okay, and once we know these the values, okay, and the reactive power we have already determined at the time of the starting, that was the Q20, okay, and that was the value was the 0 pointer, जो भी वैल्यू आई है, तो दिस इज आवर अननोन क्वांटिटीज. So basically this is the complete result after the first iterations. Now similarly we have to repeat this whole procedure for the second iteration. The important thing is that the earlier your delta 1, delta 2 and delta 3, they was the 0. Now in the second iteration, mind it carefully, only delta 1 will be the 0, while delta 2 will be this value, that is a minus 0.0367, and what is delta 31, which is the 0.029. They have to used for the second iterations. Okay, in the first iteration these all values was the 0, and then corresponding same procedure we have to repeat, and when we will repeat it, we will get at the second iteration, I am writing the final result, okay, that is delta 2 to delta 3 to the change in the power, that is a delta Pik and delta Qik when less than the epsilon. Now, what is this epsilon? The epsilon is the how much the value. For example, if epsilon is the 0.001 up to 2 digits, epsilon may be for after the decimal 3 digits, and this epsilon value will be less than this, so your iteration will be terminate and we have to stop it. In our this case, our iteration is a terminate in the second, because that's why reason our delta 21 and delta 22 both are the same, and delta 31 and delta 32 are also same, but the V21 and V22 are the different. Thank you everyone. This is the complete solution of the Newton-Raphson method for the various cases. Thank you everyone.